Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Friedel-Crafts acylation. In a Friedel-Crafts acylation, an acid chloride reacts with an aromatic ring in the presence of Al-Cl3, a Lewis acid catalyst, to introduce an acyl group onto the ring. Moving on to the next step. Identify the reagents. The acid chloride is 4-chlorobenzol chloride, ClC, is equal to O, C6H4Cl, where the ring bears a Cl at the para position relative to the carbonyl. The aromatic substrate is benzene, C6H6. Al-Cl3 is the Lewis acid catalyst. Moving on to the next step. Determine the reaction. Al-Cl3 activates the acid chloride by coordinating with the chlorine of the acyl chloride, generating an acylium ion, 4-ClC6H4CO+. This electrophilic acylium ion attacks benzene in an electrophilic aromatic substitution, EAS, reaction. And for the final step, determine the product. The acylium ion from 4-chlorobenzol chloride is 4-chlorophenyl oxocarbenium. It attacks benzene to give 4-chlorophenyl phenyl methanone, i.e., 4-chlorobenzophenon. This is a diaryl ketone where one aryl group is an unsubstituted phenyl and the other is a parachlorophenyl, connected through AC is equal to O, match with options. A shows a biphenyl type structure with C is equal to O, Cl still present. This would imply a Friedel-Crafts coupling rather than acylation, losing Cl from carbonyl incorrectly. Incorrect. B shows phenyl to chlorophenyl, methanone orthochlorobenzophenon. The starting acid chloride has Cl at para position, not ortho. Incorrect. C shows phenyl, 4-chlorophenyl, methanone parachlorobenzophenon. This matches exactly. Benzene is acylated by 4-chlorobenzol chloride to give 4-chlorobenzophenon. Correct. D shows benzophenone, PHCO-pH, with no chlorine. Loss of the para-Cl is not expected under these conditions. Incorrect. Therefore, the correct answer is C. Therefore, the correct answer is option C.